Hello, boys and girls. Based on the formative check we did, you need a little bit more review on multiplying with a two-digit number. I'm going to show you 3 ways to multiply. Let's start with this problem. 63 times 33. If you think way back, the first method we learned for multiplication of two-digit numbers was partial products. To do this, we broke 63 into 60 and 3. And then 33 into 30 and 3. Then we created our model. I wrote 60 and 3 and 30 and 3 on the sides, and then it was always helpful to me to write those numbers in the boxes. So 60 would go in the first 2 boxes, and 3, and then for the other side, 30 would go in the boxes across, and 3 would go in the boxes across, leaving me with my problems. Using my basic facts and my tens rule, I can now find my answers. 6 times 3 is 18. I put 2 zeros in my answer, and I get 1,800. 3 times 3 is 9. I put 1 zero in my answer for 90. 6 times 3 is 18. I put 1 zero in my answer for 180. And then 3 times 3 is 9. I add all 4 numbers, 1,800, 180, 90, and 9 to get my final answer. 9 plus zeros are 9. 8 plus 9 is 17. 8 plus 1 is 9, and 1 more makes 10. And 1 plus 1 is 2. So the answer is 2,079. The next method we learned used break apart, but it only broke apart 33 into 30 and 3, leaving me to multiply 63 times 30 and 63 times 3. Since 30 can be thought of as 3 tens, I can multiply 63 times 3. 3 times 3 is 9, and 3 times 6 is 18. But since it's really a 30 or 3 tens, I add the 0 to my answer. 63 times 3, 3 times 3 is 9, and 6 times 3 is 18. I add 1,890 and 189 together to get my answer. 9. 9 plus 8 is 17. 8 and 1 is 9, and 1 more is still 10. And 1 plus 1 is 2. 2,079. I got the same answer, so I must have done the problem right. To multiply with the regular algorithm, I start with the ones. I'm going to multiply my ones times my ones. 3 times 3 is 9. And my ones times my tens. 6 times 3 is 18. Now I'm going to multiply by my tens, which is also a 3. But I have to remember it's a 10 and put that placeholder 0, just like I added the 0 in my answer here. Then I do 10 times 1s. 3 times 3 is still 9. And 10 times 10s. 3 times 6 is 18. I add those numbers to get 9, 17, 10, and 2, giving me a final answer of 2,079. Notice in the algorithm how these numbers match up with my break apart method. Let's try example. This time I'm going to do 71 times 47 3 ways. First, using partial products, I break 71 into 70 and 1 and 47 into 40 and 7. I put those numbers in my model, 70, 1, 40, and 7, and then I multiply. 7 times 4 is 28 with 2 zeros. 1 times 40 is 40. 7 times 7 is 49 with 1 zero, and 1 times 7 is 7. 2,800 plus 490 plus 40 plus 7 gives me my answer, which is 7. 9 plus 4 is 13. 8 plus 1 is 9. Plus 4 is 13. And 2 plus 1 is 3. Giving me my final answer of 3,337. Now, let's solve that safe problem using break apart. This time I only break apart the 47 into 40 and 7. I think of 40 as 4 tens, and 4 times 1 is 4. 7 times 4 is 28, and I bring down my 0. Then I multiply 71 times 7. 1 times 7 is 7, and 7 times 7 is 49. I add those numbers together to get my final answer. 7 plus 0 is 7. 9 plus 4 is 13. 8 plus 1 is 9, and 4 still is 13. And 2 plus 1 is 3. So I have the same answer, 3,337. Let's solve this problem one more time using the regular algorithm. Remember, I multiply my 1s times my 1s times my 10s times my 1s, and my 10s times my 10s. 7 times 1 is 7, and 7 times 7 is 49. Since my 4 is a 40, I put my 0 in my answer, and 4 times 1 is 4. 4 times 7 is 28. I add my numbers together and still get the same answer, 3,337. It's time for you to try it. Go ahead and solve the rest of the problems on the worksheet. You can look at the video again, and you can choose any strategy: partial products, break apart, or the regular algorithm. We'll be practicing these type of problems several times over the next weeks to help refresh your memory on this type of multiplication. Good luck!